Good afternoon, everyone. My name is Patrick Conhetti. I'm an automation engineer here at Servian in Melbourne, Australia. And today, the topic of my talk is I can't do this with Terraform. What now? It's HashiTalks, so I suppose we're all familiar with the HashiCorp products. This one in particular we're talking about is Terraform. We like to use Terraform to deploy infrastructure projects, big and small. In particular, when you get on the bigger ones, you've got a plan. You think, yep, we're going to use Terraform for this project. We've got a list of all the things we're going to deploy. We start rolling them out bit by bit. And I'm doing a lot of Azure work lately. So I'll give you an example from Azure. Azure API management, the Microsoft managed API gateway type service. So we say, right, we're going to deploy one of those. We go into the Terraform documentation and we say, yep, that's supported, you beauty. So we get that deployed in our environment, and that's really good. And then we get a little bit further down the backlog, and someone says, "Oh, look, we need to connect it to a virtual network." Okay, hybrid networking on-prem, security, good. That's an important thing to do. Go back to the Terraform config and go to add in some properties, but then we hit a problem. It's not supported. The underlying API says you can attach this particular service to a virtual network, but it's not exposed in the Terraform provider. And this is the classic, I can't do this in Terraform. What now? And so the reason I wanted to do this topic was in the 6 months or so I've been working with Terraform, and mainly in Azure, but it's just, I hear it across the other clouds as well. It's a common experience, I think. You get to a point with Terraform and it's really good and it's helping you because it's managing your state for you and it supports so many different types of resources. But then you go, there's one thing it can't do, and you've got these questions. Well, what do I have to go back? I've spent weeks setting up my deployment pipeline to be Terraform. And now I've got to set up something in parallel. I've got to split it. I've got to pass data out of Terraform to some other tool and then back again. And, what happens a lot of the time is people just go, I don't like Terraform. Terraform sucks. I talk to people about why they like a particular tool. And if the answer they give me about why they like a particular infrastructure as code deployment tool is because there is a particular property on a particular resource type that's supported, I mean, to me, that's the cart driving the horse. To me, your infrastructure as code tools are about you as an engineer, as an infra coder, deploying good, robust infrastructure that's going to take, your client or business you're working for, move their business forward. You want good continuous delivery practices. These are all good things. The fact that one property out of so many things you're setting, one configuration setting, I just think there's got to be a better way. So that takes us to the real title of this talk. The real title of this talk is I can do this with Terraform, here's how. The reality is you can do anything with Terraform. It's a state management orchestration tool. We'll talk more in detail about that a bit as we get on. But it really is just a general purpose tool. Good. My screen was beeping at me and I was worried that it was someone trying to desperately tell me that my microphone was switched off. So that's good. So this talk started as a topic, and then when it was accepted, I kind of had to fill it out. And it's been through a few iterations. And where it's got to at this point is a GitHub repo that I'll post at the end of the talk. And what this is just basically notes and some sample code. It's patterns. And the idea is that we take our experiences as a community of individual engineers, individual Terraform users of hitting this roadblock of I can't do this with Terraform, now what do I do? And we all go through similar experiences trying to get around with local exec, or we might be lucky enough to stumble across the shell provider, or we might even have the Golang skills to write our own provider code. We're doing that as individuals. So this is my effort to kind of say, right, this is what I've learned, and I want to engage people to say, what do you know, so I can build on your knowledge as well. And that way we can, instead of having these situations where people hit a roadblock with one resource type and say, oh, we can't use Terraform, or we can't use that resource type. Our solution is now constrained by our infrastructure deployment tools, which is backwards, but we want to avoid that as wherever possible. What is in this repository is a bit of narrative, and then this will be posted at the end. Follow links through, a bit of a summary. It's a hard-won experience, but it's really quite simple when you actually go and write it down. Okay, so that's why we're here. I thought I would, at this point, give a little bit of information about who I am, the background I'm coming from in giving this talk, put everything in context. My name is Patrick Conhady. I'm an automation engineer at Servian in the Melbourne office in Australia. In a previous life, my continuous delivery pipeline included such tools as MediaWiki, copy and paste, and at the time it was vSphere. And there's nothing wrong with these tools as individual tools. They all have their place. But together as a pipeline, this is not a solution. This is why we love Terraform. Terraform takes care of that for us. So this is the journey I've been on personally, is embracing infrastructure as code. And in the last 6 months, I've mainly been on Azure. So all the examples in this talk are going to be Azure, but I am keen to hear from similar experiences from other clouds. Maybe it's different. Maybe it's the same. It's the kind of thing we should have a conversation. So I can do this with Terraform. Here's how. The way I'll structure the rest of this talk is I'm going to go through 4 options. There's local exec, good old built-in local exec. It's part of the configuration language. The second option is a shell provider, which is a community provider from engineer Scott Winkler, who I believe has spoken earlier this afternoon at this very conference. I'll show you a bit of what that can do, how to use that to your best advantage. Patching the provider yourself is an option. It's an option that I had written off, and then once I actually got into it, I realized it's not that scary. And the last one I put there is provider-specific templating, and we'll get to that. So first, we'll talk about local exec. Local exec is described in the official HashiCorp documentation as an escape hatch in the last resort. And look, they're not wrong. That's kind of what it looks like. It's a normal resource that we put a local exec provisioner on it, and then every time that resource is created, after it's created, we'll run that command. And we can have destroy time provisioners that will be run before a resource is destroyed. This is very handy for simple tasks. If you just want to run something, there are gotchas, and all these options have gotchas. Like the ideal is native Terraform code. That's always going to be ideal. We're in least bad territory here. So the gotchas for this option is that particularly when you attach the provisioner directly to the resource, they share the same lifecycle. So if a local exec fails, the whole resource is marked tainted, and you can't rerun the local exec without destroying and recreating the resource. You get around that somewhat by splitting the local exec out to its own null resource. This is a good pattern. It's sort of a quasi resource then, but it has no state. And that's the other gotcha for local exec. You can run arbitrary commands, and that's good. Your issue is there's no state, and which for some things will be okay. Other things, if you create anything, any kind of resource or infrastructure out in the world with your create time local exec, and then you want to destroy that later, it's going to be hard for you to find it because you can't store an ID. So that probably takes us through to the shell provider, which is the second option. Shell provider is a community provider. It's not one of the official ones. It was put together by an engineer by the name of Scott Winkler. He gave a talk today, which I look forward to catching the recording of. He also he gave a talk last year at HashiTalks, so I thought I'd share the screen grab because I quite liked it. It's he's deploying a cobblestone building in Minecraft using Terraform, so physical infrastructure in a virtual environment with Terraform. I thought that was really creative, but that approach is this approach of Terraform can do anything. To understand the shell provider, we have to go back to the question of what does Terraform actually do? And this is admittedly not a particularly elegant diagram, but the basics of Terraform is you've got a configuration, which is a desired state. You've got a state file that tracks the actual state of the world. And you've got 4 operations: create, read, update, delete. Those 4 operations are all you need. Read allows you to find out about the world and incorporate that into your state file. Create, update, and delete are how you make your mark on the world. All the shell provider does is let you supply shell scripts for each of those 4 things. That's it. It's a very simple idea, but it's very powerful. And I'll just share this comment that I found on the shell provider's GitHub repo. This is basically what Terraform should have been from the beginning. Now, obviously, Terraform is a very sophisticated piece of software, but sometimes you feel like that. Sometimes you feel like, gee, I wish I could just run a shell script and it would just manage state for me. And that's all it does for you. So I just thought I'd give you an example of what it looks like. The shell provider gives you exactly one resource type, which is the shell script type. And the building blocks are these. The lifecycle commands. So you're specifying a shell command, create, read, update, delete. Now, in this example, I'm actually calling out to PowerShell core. So obviously it's a shell, whatever is running natively on the host that's running Terraform, but you can call out to Python, you can call out to PowerShell, you could, I mean, if you wanted to, you could call out to Docker, and you can do whatever you want. The sky's the limit, it's a shell. The other thing is the environment variables. So there's no properties as such for a shell script type resource. By convention, the specification for the desired state of whatever it is we're managing, because it can be anything, will be in the environment variables. And then the shell script will receive the current state, as Terraform understands it, on standard input as a JSON encoded object. And then it's the responsibility of those shell scripts, particularly the read one, to emit a JSON object, a map of strings, that's going to be the new state. Now, what I'll point out on this slide is that the state that you output from these shell scripts becomes available just as any other attribute from any other resource would be in Terraform. So we're not going out of Terraform and having to find some back channel for communicating back into Terraform. We're staying within the Terraform environment. We're staying integrated, and we're seeing that information back and forth in a really neat way. What I've done on occasion with the shell provider is written a Terraform module that under the hood uses the shell provider to provide its functionality. And then when the official provider came along later, or when the official provider's functionality expanded to cover the resources and properties I was interested in, I could swap out the underlying implementation. Shell provider is just another resource. So the benefits of it are obvious. The gotchas that I want to highlight is once you understand the gotchas, you can get a lot done. Once you understand these are the things you have to watch out for, as long as you watch out for these things, go crazy and you won't have any problems. First one is ensuring that the provider is available on the host. If you're using something like Terraform Enterprise, or if you are running Docker if you're running Terraform in a Docker container, you can solve that problem quite easily. The scripts are difficult to debug. This is something that's common about the way Terraform deals with its providers. The debug output is like, you can't do print statements easily. Now, there are ways to do that. So there are patterns in existence for doing exactly that. Parsing and building JSON, again, it's not a native thing in shell scripts. Shell scripts are line-oriented, but there are tools like JQ around, which allow you to bridge that gap. The next one that I wanted to talk about was patching the provider yourself. So this is writing some Golang. Now, to me, I have on occasion looked at Golang, and I've looked at providers, and there's like 80,000 source code files, and I've just thought, no, I have no idea where to start. I have no idea where to start, and so I've had a plan to set aside some time to learn Golang, and then once I had learned Golang, I would be able to do Terraform provider development because I had issues with the behavior of a particular provider, and there was nothing I could do about it. And I thought, right, once I know Golang, I can come back and do it. I realized that's backwards. You see, provider development is very formulaic. It's not easy as such. Obviously, particularly when you have to do the whole provider, it's a big job. But you just need to do one thing on an existing provider, particularly when it's an existing provider, existing resource, and you just need to add a property that's missing, like a new function that the cloud provider added, and you just want to make sure it's supported in Terraform. There's a formula. This slide is giving a bit of a conceptual overview. At the top of the tree, we've got the Terraform config that you or your user will write. That is interpreted through a Terraform provider, which is written in Golang, which consists of a schema, and in particular, following a particular protocol that Terraform understands, and that's what makes it a provider. What the schema specifies is resources and the properties of those resources, and it specifies the create, read, update, and delete functions for each resource. Terraform providers don't actually implement any logic, not much logic. They are a thin layer on top of the cloud provider's SDK. If there is no SDK for a given subject matter, the recommendation is that you build an SDK and then build a Terraform provider on top of that, rather than try and do SDK work and go directly from Terraform to API in the one thing. What this means is that, for instance, in my earlier example, at the start of the talk, where I wanted to attach an API management service to a virtual network, that's the code to add that to the schema. Like that's not intimidating. That looks almost like, it doesn't look quite like Terraform, but if you can do Terraform, you can do this. Like, this is not, you don't need a computer science degree or anything even. This is just, a lot of this is copy and paste. This is to tell it what subnet ID to attach the API management instance to. Like, it's all you're telling it is, this is the name of the variable and this is its type. This is the constraints I want to put on permissible input. The second thing you have to do is obviously glue up wire up the create, read, update, delete aspects. In a provider like the Azure provider, so much of that is already handled for you. And you have, for instance, here, what's on the screen at the moment is some pre-existing code that deals with aspects of the API management instance. And these 5 or 6 lines is all I had to add. Everything else was already there. Now, I didn't write that from scratch. That is largely me looking around the surrounding code and finding things that looked superficially like what I thought I needed to do. Because remember, I don't know Golang. I'm copying and pasting and then copying the names of the properties from the SDK source code. So this is not there's no rocket science. It's actually a lot easier than you might think. So the message here is, don't be deterred by the fact that it's Golang. You may actually be able to solve the problem. And then these providers come with good make files. So it's Go, install Go. It's easy to do on a Mac. Make build, did a build, great. You get a binary, stick that in your Terraform plugins directory, run your Terraform config with the new properties. If it crashes, work out why. If it doesn't crash, great, fantastic, problem solved. If you've got good continuous delivery procedures around your project, or if it's just a proof of concept, you'll find the risk associated with pushing the boundaries, or even if you don't necessarily go belt and braces with testing your new Go code or having all the documentation there, you can get the job done. It's quite feasible. The gotchas to watch out for with this option are, you have to learn Golang, sort of. The comments I've made about it being very straightforward to add support for properties is very much around when it's an existing SDK, existing provider, existing resource, and just adding a property. As you go up that hierarchy, if you're adding a new resource entirely, that's a lot of complexity. A new provider, a lot of complexity. No SDK, a lot of complexity again. So then you are getting into a large programming undertaking. Maybe the shell provider is the better option if there's already an existing command line interface or an API that you can write some curls against. Now, this is actually the second last slide, so we're not doing too bad for time. The last option that I've got here is provider-specific templating. And so this might mean for Azure ARM templates, or it might mean CloudFormation for AWS. What I had in mind when putting this together was to collect samples and case studies. I don't have case studies for this. I just haven't found the need for it because I found that the other three have solved my problems. But I'm keen to hear from people who have found success integrating ARM templates in particular into Terraform configurations, because it's one thing to say, okay, I've got this set of Terraform config and I've got this set of ARM templates and they run at the same time, but getting them to work as harmoniously as possible together, having a good playbook for doing that, I think is a really important way to be able to do everything possible with Terraform. That's it for my talk. Before I finish the talk, quick word about Servian. We're in, where are we now? 10 locations. That's a lot more than it was even 6 months ago. So if we don't have an office near you yet, we will soon. So get in touch. And that's the end of my talk. Thank you very much.